All right, so the next thing we're going to be talking about here for this segment of the video is what we'll understand as the properties of logs or logarithms. Okay. So in class, right, often you'll be given sort of setups that have a bunch of logs that are added to each other, divided by, or added, subtracted, raised to certain powers, so on and so forth. And you're a lot of times asked to expand or contract these, or really also to just solve for x, okay? And the key to these problems often lies with these properties, okay? Now there are three main properties that we're going to use to solve these problems, okay? The first one is called the product rule. The product rule, okay? Now the product rule says that log of a number, log base number of a certain number, we'll call it m, okay, plus log of a number n, okay, is equal to log of m times n times n, okay? So we bring these together and multiply them. Now, really important here, what you should recognize is that we have the same base, okay? You have to have the same base in order for these properties to work, okay? This is true for all of these properties. Same base. If you don't have the same base, it does not work. Okay. Our second property is what we call the quotient rule. Okay. Now you can probably guess what this is going to be based on our last example. All right. In the same way that we have the product rule, we also have a similar quotient rule, which says log b of m minus log b n is equal to, all right, you can probably guess what's coming up, log b m divided by n, okay, because it's the quotient rule, division. All right, again, we have the same base, and then we have m minus n, so that becomes m divided by n. And then lastly, we have what's called the power rule. Power rule. All right. Now, when we have the power rule, this is when we have a number, call it p, times log base, and we will stick with m here. Okay. This becomes p moves. So we have log base m to the p power. So the p basically comes around and is brought to the power. All right, so these are our three rules that are going to be the basis of solving these types of problems. Okay, these three rules. So let's try some examples and see how we might apply such rules. Okay, now the first is going to be simply in kind of expanding or contracting certain ones. Okay, so let's start with something like say log of 4 plus log of 3. Okay, see if you can figure that on your own. All right, so what you should see here, okay, is that if we just have log, remember we're assumed to have a base of 10, okay? So we can imagine there to be a base of 10. So that follows our first rule, which is that we need the same base. So that's good to go. And then we have log of 4 times 3 because of the product rule. We bring these together, and then that becomes log of 12. And that's simplified. Good to go there. Now this might be equal to something, in which case that would expand the problem that you have to do. But in this case, right, we're just simply simplifying, basically. All right, now let's try another one. So for this one, we're going to have log base 5 of, say, 72 minus log base 5 of, let's say, 8. All right. So try to figure out what that's going to be. All right, first question you should have asked is, do they have the same base? Which they do, so that means we can work with them using our rules. So we bring these together, okay? And we get log base 5 of 72 divided by 8, okay? And we know, of course, that 72 divided by 8 is log 5 of 9 And that's your answer, log 5 of 9. That's simplified. All right, let's do another one. Say we have 3 times log base 4 of 4. Okay, so see if you can simplify that. All right, so what we know, right, is that when we have a multiplied number outside, we can bring it as an exponent inside the log. So this becomes log 4 of 4 to the 3rd power. And we know that 4 to the 3rd power is going to give us 64. So this is log 4 of 64. All right, and that's that. Okay. Not too bad, these properties. Where it gets a little trickier is when you have to solve these out algebraically or using variables. So that's what we'll do for the rest of this video, is do some worked examples, and I'll let you try them on your own, and then I'll walk you through them to make sure that you understand it. Okay, so the first one we're going to do is log, we'll say log b, just for base, of x, y over z. This is something you might see in class. All right, so try to expand this, okay? Expand. All right, so hopefully you gave it a try and expanded. Now, we will do this typically one step at a time here, okay? So according to order of operations, it's a good way to think about it, right? We'll say, okay, log base of x, y, okay, minus log base z, okay? Now we did this using the quotient property. Okay, quotient property. And then the next step will be log base x plus log base y minus log base z. Okay, so we split this up using the product property. Okay, so use both properties, and then this would be our fully expanded answer. Okay, so let's try one that's a little harder here. Which requires a couple more steps. So, say we had log 2 of, we'll say, 8x cubed. I'm going to write that a little neater. 8x cubed over 2y. Okay. So see if you can expand that on your own. And also just make note of the properties that you're using as you do it. Okay, so first things first is we can go ahead and break up using, again, let's think about kind of order of operations here. So think back to algebra, your algebra days here. So, or your algebra 1 day. So if we go log 2, 8x cubed. I keep doing that 3 a little messy. 8x cubed, okay, minus log 2 of 2y. All right, so we split that up using the quotient property. All right, now let's split up the rest of these. Now we'll get, okay, log, we can say, okay, log 2, 8. Okay, splitting this up, plus log 2 x cubed minus log 2 plus log 2y. Okay, so we split all of this up using the product property. So we started with quotient property, and then we split it up using the product property. All right, now this gets a little trickier because now there's certain ways that we can simplify when we have these logs of certain numbers, right? So log 2, 8, right? If we were to solve this over here, okay, so we would say, all right, log base 2 of 8 is equal to what, right? We would say that 2 to the what power is equal to 8. Well, we know that 2 times 2 is 4, times 2 is 8, so 2 to the third power is equal to 8. All right, so this down here is going to just become 3. So then we have 3 plus, okay, now we can use the power rule to bring this over here. So we have 3 times log 2x minus, similar thing going on here. So we have log base 2 of 2. So let's see what that's going to give us. All right, so we have log 2 of 2. Now, if you'll remember, any time we have something to itself, it's always going to equal 1, right? Because 2 to the 1 power is going to equal 2. So then this is just going to become 1. And then we have plus log 2 of y. All right. And that'll actually, then we can combine like terms here, right? So we'll have this and this can combine to become 2 because 3 minus 1 is 2. So that means our final answer will be 2 plus 3 log 2x and then minus log 2y. Now, what I should have actually done here to make sure you see this, right, is we actually want to think of this as all in parentheses here, in parentheses, okay? Because we'll need to distribute this negative, same down here, all right, it's in parentheses. So what we did here, right, is we took this negative sign and distributed it, so that became -1, but then we also distributed it to this log, and that's why this right here is negative, because we have negative log. So that's your final answer. All right, so as we can see, they do get a bit more complex as we go along. All right, let's try a couple more, and we'll just kind of keep increasing the complexity of this as we go along. So let's say we have something like 2 log b4 plus log b5 minus log b10 is equal to log b of x. Okay? See if you can simplify this, and if you can, see if you can figure out what x is going to be. We haven't quite gone over the property, but you might be able to figure it out. Okay, so if we start condensing all of this, all right, we will first use the product rule. Okay, so that's going to become log b4 to the second power. Okay, so then we'll have log b4 squared, okay, plus log b5 minus log b10 is equal to log b of x. Okay, so that was the power rule. All right, now let's use the product rule, and so we'll get log b 4 squared, right? That's just going to be 16. Okay, so we'll have 16 times 5. All right, 16 times 5, which is going to give us 80. Okay, so log b80, all we did was 4 squared times 5, 16 times 5, minus log b10 is equal to log bx. All right, now we're going to use the quotient rule, okay, and this is going to become log b of 80 divided by 10. All right, now that's going to simplify to become 8. So this is log b8 is equal to log b of x. Okay, now this is the part that we haven't quite talked about yet, but might be sort of self-evident if you think about it. What we're doing here is that we have the same base, okay? Same base. Again, this is the key with all these properties. This is the same base. So we have the same base here, all right? And then we have just two numbers. So that actually means that we can just say that this entity is equal to this. So x would just be 8. Okay, you can kind of think about it. Log of 8, right, is equal to log of something. Well, that something has got to be just 8. So it becomes 8. All right, nice work. So now let's try using that property we actually just talked about with one that's more algebraically oriented. So we have log of 5x is equal to log of 2x plus 9. All right, see if you can figure that out on your own. All right, so what we should see here is that when we have the same base, which we do, we imagine this to be 10, right? We imagine this to be 10 when there's nothing there. So we can just get rid of the logs, and we can actually just say that 5x is equal to 2x plus 9. Because when we have the same base, we just set them equal to each other. So then we subtract 2x, and we're going to get 3x is equal to 9. Now we divide by 3, so x would equal 3. All right, easy enough, right? So now let's try one that maybe has a couple more steps, but is similar in approach. So we'll do let's do log of base 4 of x plus 2 minus log base 4 of 4. And actually I'm going to change this to just log base 10. I think it's going to make it a little easier on us. So log of x plus 2 minus log of 4 is equal to log of 3x. All right, see if you can solve this on your own. Okay, so we have the same base, 10, okay? So that means we can use the quotient rule here. So we have log x plus 2 over 4 is equal to log 3x, okay? All I did was bring these together using the quotient rule. Now we have the same base and they're set equal, so we can get rid of these logs, right? Just get rid of these, and this is going to become x plus 2 over 4 is equal to 3x. All right, now we multiply by 4, multiply by 4, and we get x plus 2 is equal to 12x minus x minus x. We get 2 equals 11x. Now we're going to divide by 11. So x would equal just 2 over 11. All right. Now what you'll notice is that it actually doesn't matter what the base is here, right? Which is why it might be log b or log 4 or log anything, right? Because when they're all the same and with these sorts of setups, it actually doesn't matter what your base is. Okay, moving right along. So let's do a setup where we're going to have to do some quadratic setups, because that's kind of usually about as hard as they get. So say we have log base 9 of negative 11x plus 2 is equal to log base 9 of x squared plus 30. All right, see if you can figure this out on your own. So hopefully you gave it a try, and immediately we should see, okay, got the same base. So that's nice. We can just say, boom, get rid of these guys, and we say negative 11x plus 2 is equal to x squared plus 30. All right. Now, whenever we have a setup like this, right, we always want to get 0 on one side so we can factor, right? So we will subtract. We can start with subtracting 2. Sometimes that's easier to think about it that way. Negative 11x is equal to x squared. Now we can only do here, right? So it's x squared plus 28. Okay. Now we're going to add 11x, add 11x. Okay, there's no like term there with 11x, so we have 0 is equal to x squared plus 11x plus 28. Okay, now we're going to think about factoring. Now we'll have another video on factoring if you need to review that, so I'm not going to go through it in great detail, but I'll just quickly do my little method that I like. When we don't have a lead coefficient here, we can just kind of think, okay, we have a big X here, right? We need a number that's going to multiply to get 28, multiply to get 28, and add up to get 11x. Okay, add up to get 11. Now, what two numbers fit that criteria? Well, we'll say, all right, 7 and 4 fit that criteria, because 7 times 4 is 28. 7 plus 4 is all 11. All right, so that's going to leave us with, and again, this only works when you don't have a lead coefficient. We'll have another video that goes through factoring in more detail. But we have 0 is equal to x plus 7 times x plus 4. All right, now if you want to test this, you could FOIL it out and we'd get back to this point. All right, now we now know that each of these can be equal to 0, right? So we have 0 is equal to x plus 7, and 0 is equal to x plus 4. because if one of these was 0, it would give you 0 overall. So then we just subtract 7, subtract 7, subtract 4, subtract 4. All right, and this gives us x equals -7 and x equals -4. And these are our two answers here. All right. So as you can see, when doing logs, a lot of the setups are simply testing your knowledge of how logs are generally set up, right? Testing your knowledge of the properties of logs. And then after that, after you get that initial setup, it's really then just applying knowledge that you already have of algebra, and then using your knowledge of algebra and just starting with logs and then moving on to just kind of solving algebraic equations. All right, I hope that helps, and I will see you next time.